Hello and welcome to the Lightning Talks on day 3. It's cool that you're here. So my name is Theresa. I'm going to be the moderator for today. And yeah, so unfortunately, as you can see, Nick Farr is not here today, but he wished he was. So he really he wished that he could also attend the Congress, but he will be watching the streams live from Times Square. And look, he's wearing a hoodie just for you. Awesome. All right, so for those of you who haven't attended a Lightning Talk session before, Lightning Talks are basically 5 minutes per speaker. You can talk about whatever you want. You can present your crazy idea, your projects, your whatever you're interested in. And for keeping the 5 minutes, we have our timekeeper, which which we already sort of demonstrated before the talk. So the bar fills up with green for the first 4 minutes, and now we are fast forwarding it a little bit so you can get an idea. So this is 4 minutes of your 5 minutes, okay? And then when it's full, you have 1 minute left, and then the yellow starts. So yellow is also filling up the bar until you have 30 seconds left, and with the last 30 seconds, there's this red coming up. And yeah, so for the last 5 seconds, it's blinking like that. And do you know what to do? Can we?
4, 3, 2, 1.
Well, okay, that was a little bit quiet. So look, Nick Farr is going a little bit like that right now. So can we try again?
8, 7, 6, 5, 4, 3, 2, 1, and...
That's more like it. All right, so for the speakers, it's awesome that you're presenting. Please sit somewhere at the front if possible, so you can quickly walk up to the stage. And I have this clicker tool, so you don't have to say slide, but you can just advance the slide yourself. Please talk into the microphone. So here's the speaker's microphone, and sometimes you know these microphones tend to do these weird things where actually nobody can hear you if you move away from the mic or if it's like that or like that. So please think about adjusting the microphone. And yeah, so you don't actually have to look back on your slides because they're right here in front of you. So just a reminder. Yeah, so have fun. Oh yeah, translations are available. So most talks are going to be in English, and all the talks are going to be translated. So the English talks into German, obviously. I'm repeating this in German. Okay, für die Menschen unter euch, die nur Deutsch sprechen, die Talks werden übersetzt, und zwar unter dieser angezeigten Nummer, DECT 8014, habt ihr eine Live-Übersetzung. Yeah, so now everything that's left for me is just to wish you a great session and invite my first speaker about the RIPE Atlas Hackathon. Just a sec.
Hi everyone, I'm Vesna, and I'm here to invite you to a DataViz hackathon based on the RIPE Atlas open data. I'm community builder for the measurements tools at RIPE NCC, and I'm also part of the hackerspace in Amsterdam called Technologia Incognita. This is my 4th Congress. I never managed to get the proper speaking slot, so I have to do lightning talks instead. So the summary is there will be a hackathon in Amsterdam end of March. You are invited if you are interested in programming, design, visualizations, analysis of data, open data, and combining your skills with the skills of other people. It's going to be quite intensive, but not 24/7, so you'll also have time to see Amsterdam and enjoy yourself. It's going to happen in the offices of the RIPE NCC and in another location that we still didn't really agree on, but maybe it's going to be a hackerspace. And we also have prizes. We got a sponsor who is going to provide for the partially covered travel expenses and accommodation. So there will be several people selected who cannot afford to come to Amsterdam by themselves. So we will cover some of their expenses from the money of our sponsor, and there will be prizes. There will be money for the three most successful teams. This sponsor is Comcast, who is using RIPE Atlas data, but they don't have time to actually make the source or the code themselves, so they want to pay somebody else to do it and release it back to the community. So this is the link for application. Now this was for the people who actually know what RIPE Atlas is, and now I'm going to do an introduction into what RIPE Atlas is. I have another 15 slides and I will talk very fast. So RIPE Atlas is the active internet measurements network, which consists of 7,500 hardware probes hosted by volunteers around the world. This is the hardware. There are small probes. Currently, we are distributing TP links, which are not wireless routers anymore because we have installed something else on them. And then there are bigger boxes, which are anchors. What can you do? You can do ping, traceroute, and DNS measurements with them. This is one of the visualizations. This is another one. These are many more. Wikimedia used it. Open IP maps are based on this data, but it's actually like crowdsourced traceroute geolocation of the infrastructure. So take part in this too. Some other researchers used it to show the interference detection, and a lot of hackerspaces actually have a RIPE Atlas probe, and on the hackerspaces.org you can mark your hackerspace with this and that you have a probe, and it will show on this map. This is the documentation, so all the data is open, there's API to access it, there's a lot of code published on GitHub. These are our repositories there, and this is how to get in touch. I will be here still tomorrow doing the workshop on IPv4 hijacks and IPv6 deployment tomorrow morning at 11, which is totally too early, I know, but that was the only available slot. And if you're interested in internet governance or any of the other services of RIPE NCC or anything to do with the RIPE community, talk to me. There is a lot of other people from the RIPE community here, so you are probably one of them also. So if you want to discuss any of the policy development process, governance, any of the other things like KRoot or more about RIPE Atlas, please come talk to me. And if you want to go to the hackathon, going back is this link. Thank you.
Please just wait for the next speaker to hand over the clicker.
Any questions? See me later.
Okay, hi, I hate podiums, but whatever. So my name is Yuval, and I'm going to present a project I've been working on. It's a POC project right now. I hope it can expand further. It's called Amentes, and the clickbait title is Eyes Only Document Viewing. So the scenario that we kind of have in mind is the one that most of us are familiar with. It's Snowden and Glenn Greenwald, basically Snowden handing over documents, a stash of lots of documents to Glenn Greenwald. And I was thinking, how they did this and how this could happen in other scenarios when whistleblowers need to deliver documents to journalists. And most of us are familiar with all the leaking platforms, the online leaking platforms that we all know. And I'm more interested in kind of the offline world about how this is actually done. So Amentes is basically three things wrapped in one. It's a live USB. It's a hardened desktop that runs off of that live USB that you can boot, and it's an encrypted partition. So basically, what Amentes will allow us is a technical user. This isn't for non-technical users just yet. So the sending party would be running Arch Linux because this is what it's currently implemented on. That user will collect a stash of files that he or she would like to deliver to a trusted party. And then that party would run the Amenthys build scripts, which are built on the awesome make Archizo scripts, which allow you to build a live USB system. And then the result is an ISO file that you can just transfer over to a USB, and then you have a live USB system. This basically just simplifies most of the work that the competent system administrator such as Snowden would be doing by himself. Just typing in some commands, this kind of just wraps it all in one nice little package. The delivery is done via SneakerNet, so we're talking about offline delivery, not online. So this means someone in the vicinity of a journalist would be handing this over or sending it by mail. And again, the USB is all the files are encrypted, so that means the delivery of the passphrase needed to open the encrypted partition needs to be delivered separately. So you wouldn't be sending the same passphrase inside the envelope or the mail. You'd have to either call by phone or some other trusted way to deliver the passphrase. The journalist or the end user would then boot the Amenthys Live USB. We'll receive a very lightweight desktop built on LXDE. There's a small script that would run initially that decrypts and mounts the encrypted payload and all the necessary document and media viewers that you need to view the actual files, the payload. The desktop is hardened against accidental leakage. So that means that networks and mounts are disabled so that the files can't accidentally leak out of this system, so they're kind of enclosed in a single system. This isn't hardened against, basically, Amenthys kind of assumes that the party that we're delivering the files to is a trusted party, and that he or she won't actively try to extract the files from the system, because that is possible if you kind of understand how this works. So that's the whole idea. The code is on GitHub. That's the address. There are many different ways that this project can expand, and I'm really interested in feedback from people who are interested in this. Basically, I would like to see this expand into a possible platform for non-technical people to actually enclose a delivery of a payload of files that are supposed to be leaked or pertaining to a whistleblowing situation. And I think the USB platform, the live USB platform that is delivered on, gives pretty good assurances that as long as you trust the party that is receiving these files, they can't easily be extracted from the system. Again, not including firmware attacks or bad BIOS attacks or stuff like that. So as long as the system is running, then it should be good. That's it. Please talk to me if this interests you and if you want to work on this, and check out the code. There are some test builds. You can just download it. If you don't have Arch Linux, you can just download. There's an ISO file created on, there's a link there on the GitHub as well. So you can just download it and try it out yourself on a VM and see how it looks. That's it. Thanks a lot.
Please, for the next speaker, always, when you see the end of the talk coming near, please come to the front, come to the podium, so you are here.
Thank you. Okay, let's start. All right. My name is Sarah. I wrote a tool I like to share with you. It's called CatNode. It's short for Cademia Node, and it's a peer-to-peer DNS-like system. It's not really DNS. What it does, it finds IP addresses by some identifier, but the main task is that it's decentralized and has a low footprint. You can install it on routers, but there are also packages for Windows, Mac OS X, whatever. And well, it's not really it doesn't have a domain registry, so it's not really DNS. How it works? It's a distributed hash table. It uses a hash table by transmission BitTorrent client, and it intercepts, for example, the .p2p domain, top-level domain, and uses local DNS service, some sort of system interface to use the distributed hash table to get IP addresses. So it's like, the setup, you say, okay, my server, my laptop should have my name peer-to-peer, and you enter it in a browser, and then it resolves to the IP address of your server. You can also use hexadecimal string, so it's 20 bytes like in a bitrent client. And you can use, for example, the Debian bitrent tracker for bootstrapping or local peer discovery. So it's basically like something like that. This, you enter your name, my name, .peer-to-peer in your browser or on the console, and, well, it will work. But it might take a few seconds. It's not that fast yet. So typical issues, okay, everybody can announce an identifier. It doesn't have really authentication. I tried something, but it's not that secure, so I won't advertise it. And, well, it's a bit hard because the browser gets a few IP addresses. For example, if many people are announcing my name.peer-to-peer, they want this domain. And, okay, the browser, okay, I think it would be a good idea if the browser decides by HTTPS which IP address is right, but the browser doesn't really support something like that. It doesn't try multiple IP addresses and say, oh, okay, it doesn't work. Oh, this one is all right. And there's also no DNS backchannel to say, hey, Catnode, please ban that imposter, something like that. Features, yeah, it's dual stack, written in C, small, local peer discovery, and it's available for OpenWRT, Debian, Arch Linux, OS X, Windows, FreeBSD. There are packages. Yeah, and that's it. Thanks. You can find me in the Freifunk assembly, and we can talk about it. Maybe you have ideas how to solve some issues, how to make it more usable. Thank you very much.
We have more than 1 minute left, so do you want? Okay, then we continue, and maybe we need the time later.
Okay, start. Roguelikes and how to build one. Roguelikes are games inspired by the 1980 Unix game Rogue that looked like this. It depicted its game world in a top-down view drawn as ASCII characters. You were the @ symbol, a player walking through a dungeon, collecting items, killing monsters, shown here as letters of the alphabet. Rogue was turn-based and had to be played very carefully and strategically, because there were no earlier save games to revert to if anything bad happened to you. If your player died, you had to start a new game in an entirely new random world, and that was always generated procedurally at game start. Rogue spawned an entire tradition of games that copied great parts or all of its features and scenarios. Here's just some of the most popular ones, but in fact there's many, many hundreds more. Since the 1990s, there's been a whole community of people who enjoy building roguelikes, often as one-man or woman projects, who mingle on IRC, Usenet, and even an annual conference. One thing that lures many coders into this is, I think, that it's easy to quickly jump to the interesting coding tasks without bothering much with graphics or UI design. The community still pretty much accepts delivering games with a 1980s ASCII terminal-style interface, so that frees developers to instead focus on playing around with game mechanics or procedural algorithms to generate interesting worlds or monster behaviors. Now, to give you a sort of an impression of how to start your own roguelike, I'll just describe the basic design steps that I started with. I did my own roguelike work in C and N curses, but I won't go into any code details here. I basically put a movable @ symbol on an empty map of dot symbols. Imagine these as ground to stand or move on. I surrounded these with a random sea of tilde symbols. Imagine these as sea or water that my @ symbol could not cross. So I had a sort of an island, and I put on that letters. Imagine these as actors, just like the @ symbol, but not controlled by the player. I gave each actor a set of hit points that once they reached 0 would make this actor disappear or die. This would happen by, for example, one actor moving next to another and from there moving into him, thereby attacking him. And the attacked actor's hit points would decrease by 1. So I could now walk around this island and kill off all these letters, which is kind of boring. So I had decided they had to move and attack too. I made them on each turn try to move towards the nearest other actor, and if they would stand next to it, attack it. So I had to give all actors not controlled by the player some basic pathfinding algorithm. To make that more interesting, I put some more obstacles on the map, these crosses, and to make these obstacles more interesting, I decided they should not just block movement, but also view, so that from any given point of view on the map, areas behind these crosses would be hidden. This would, for example, allow actors to hide from other actors. So I already had quite a complex setup with some simple design steps. And now I also decided to make things more interesting, to put items on the map. Food that one could, for example, collect to eat and thereby gain hit points. This could be done by the player, but also by the other actors, who would now each turn have to decide whether to hunt other actors or whether to hunt food and get more healthy. As you see, I like giving player and other actors some symmetry in what they can do and know. So one thing where the player has an unfair advantage is that he can make notes about what the map looks like. So for example, once he leaves an area and cannot see it anymore, he still remembers that this is maybe a path, a shortcut to find shorter paths from A to B. To give also the other actors this ability to remember parts of the map, I implemented automatic map memory. So this is a screenshot of the game as it looks on my X-term. On the right-hand side, you see the map as seen from the player, and the black background, white foreground cells are what is currently in the player's field of view. The black background, blue foreground cells are what was previously in the player's field of view and is remembered by him, and the entirely blue ones are, well, entirely unknown parts of the map. I then split my game into server and client. The server contains the game logic and game state. The client is just the interface, as you just saw it, easily to be replaced by a nicer X client, etc. Server and client communicate by reading and writing text files in a file system that can easily be analyzed and manipulated by external tools to, for example, manipulate the game state during the game run and thereby cheat, or to script and automatize game player behavior. So these are some, it's just some chronology of steps one may take to go through the game and build one's own roguelike. And do yourself on scratch, I can only recommend doing it. Thank you.
So hi everybody, I'm going to talk about the OpenText research project. So before starting, I'd like to give you some reminders about the evil maid attack. So basically it involves 3 actors, an evil maid, a poor innocent guy, and a FDE encrypted laptop. So the laptop is encrypted with some kind of BitLocker or TrueCrypt. And the main idea is that the evil maid comes, cleans the room, and then install a malware on the laptop. The malware exposes a fake prompt for the passphrase, and then the innocent guy type in his passphrase, and the passphrase is exfiltrated or stored locally so that when the maid comes back, she can steal the laptop and the passphrase, so she has access to the decrypted content. So what is the problem? The problem is that how do you trust your laptop when you comes back to your hotel room? So during the OpenText project, we had 2 objectives. The first one was to focus on user trust on his own laptop. So this led to one contribution, which is a secure boot on Linux. And the other objective was to focus on isolated execution so that critical code can be executed in a protected environment. Here I will only focus on the secure boot. So secure boot, what it is, it's integrity verification at OS startup. And the idea is to provide some proof of integrity to the user. So there is different kind of proofs, and we focused on 1. The first one is the secret banner. It allows to share a secret, such as a text or image, between the TCB, Trusted Computing Base, and the user, so that this secret banner is encrypted, and it can only be decrypted if the platform integrity is correct. And we also work on another use case, which involves remote attestation through Android. So let's have a look at the secure boot architecture. So during the OpenText project, we developed different libraries and use cases. And we especially developed the TPM 1.2 library, which is autonomous from the BIOS and operating system. We also developed IR stack for the TPM. And we implemented two use cases, a static chain of trust scenario, so that everything is measured at startup, and a dynamic root of trust, so that everything is measured at the OS startup, but it provides better security because of the IOMMU protection, so that DMA access cannot be an attack anymore. So this is the architecture, the sequence of the startup, and we developed what is before the DRTM, the dynamic root of trust sequence. Especially, we developed one component, which is the OpenDetect MLE. It takes as input many stuffs, the secret banner, the Linux kernel, and everything is measured, so that when the integrity of the Linux kernel is okay, I can see the picture, and if I see this cute little cat, it means that my platform integrity is okay. Okay, so as a conclusion, during this project, we focus on secure boot. So we provide remote attestations through Android and secret banners so that we can be confident of our integrity of the operating system. It works either on the static or dynamic way. Obviously, it doesn't target everything, so that if you have a hidden camera or if you have a hardware keylogger, it doesn't protect you against that. Okay, so if you have a question, please ask me after the talk.
Okay, so this talk focuses on the field of protocol reverse engineering, and its objective is to provide a tool that is called NetZob that can be useful for security experts in the work of reversing protocols, such as the ones that were presented during previous conferences or previous talks, such as during the cyber necromancy talk or the SatPhone hacking process, where security experts had to face unknown protocols and had to reverse them. So just to remind you, a protocol is made of two distinct parts. The first one is a vocabulary and the other one is a grammar of the protocol. The first one specifies a list of messages that is accepted by the protocol and their format, such as with the TCP protocol and the SYN, ACK and SYNACK messages. And the other one specifies the procedure rules that governs all the valid exchanges accepted by the protocol. For example, here we have the state machine of the TCP protocol, and our objective is to infer this state machine. So it exists two approaches to infer the grammar of a protocol, a passive one or an active one. The passive relies on samples of communication traces from which you try to generalize and create a model, mostly based on prefix tree acceptors and so on. And you try to create a model that accepts all the sequences of message you've observed and that may accept the ones you didn't observe. The other approach is an active approach, is the one I prefer, because you stimulate the implementation and try to infer and to discover all the valid exchanges accepted by the protocol implementation. And theoretically, it's provide completeness and correctness of the inferred state machine. So the state-of-the-art algorithm in this field is called L-star. It's proposed by Angwin, and it relies on two blocks. The first one is the implementation from which you want to extract the state machine and the inference process. So you first create an observation table, you try to upgrade it using membership queries, which means you stimulate the implementation with specified inputs, and based on the outputs, you upgrade the observation table. Once you reach a certain level, you can create a hypothesis automaton, and then you can try to verify that this hypothesis automaton is valid by means of a B simulation, which means that you try to find for counterexample between your hypothesis automaton and the implementations. If you find a counterexample, you can refine your hypothesis automaton, such as creating new states, and start again your inference process. Whereas if you don't find any counterexample, it means that you successfully inferred the state machine. So in practical, you can use this L-star algorithm. I successfully applied this algorithm to implement various state machines. So for example, you can use the LearnLib implementation, which is an open source implementation of the L-star algorithm. You simply have to create your own system underlining process, proxy, which means you implement the open connection, the closed connection methods, and how you send queries to the implementations. And based on this, you can you execute the L-star inference process, which can take a few hours. And finally, you can perhaps retrieve the state machine of the protocol. So for example, I apply this algorithm to the botnet, a very simple botnet. The P-bot, it's an IRC malware. And I successfully applied to infer its state machine. And based on such knowledge, you can then try to create some further, smart further, or try to validate or execute security evaluations of your botnet or of your adversary botnet. You can also apply such technique on more common protocols, for example here on the IRC, but I also apply it on the Samba protocol. I cannot show you here because it's very large, but I successfully inferred the Samba protocol after 10 hours of computation. So all this work was done as part of the NetZob project, which is a tool that can be useful for security experts in the protocol reverse engineering processes. So if you need help in reversing protocols, or if you want to help us, please contact and join us. Thank you.
So hi everybody, my name is Dimitri Kirchner and I will present to you today Hooker, which is a solution to analyze the Android market. So the main assessment here is that analysis tools are today centered on one specific application. We wanted to know is it relevant to analyze more than one application at a time? Can we have results by analyzing an entire market? So that's why we created Hooker. Well, it's a solution to analyze a lot of Android applications. And when it analyzes these applications, it sends all the results to a distributed database. And yeah, it's called Hooker because it hook calls to the Android API during our dynamic analysis. So how Hooker works in 3 steps. So step 1 is just analysis of one application. Step 2 is automation and parallelization of step 1. And step 3, yeah, it's just profit. So this is the global overview of step 1. What you do is you take an application in input, you do some static analysis using AndroGuard, you do some dynamic analysis using the Substrate framework, and you send all these results into a distributed database, which is Elasticsearch, and then you can do data mining either by using Kibana or also Python script. So the interesting part here is Substrate, the dynamic analysis using Substrate framework. I'm not going to enter into how Substrate works because it's quite difficult, but basically it injects itself into every applications you have. And when one application is calling the Android API, what we do with Hooker is building an event object in real time that contains every information we need to do some further analysis. We send this to a collect service, which will then send it to the database. So just to give you an example of how an event object look like, it's here interpreted by Kibana web interface. So you have all the information you need. You have timestamp of when the event was. You have the package name with which made the call, and you have the class name, the method name. So here it's JavaScript cipher with method name in it. So if you look at the parameter, you can see the different the algorithm which is used, and the key, the secret key which is used. So that's just to show you that we have a lot of information when we do this. So then post-analysis is just like data mining within millions of events we have in the database. So we do this either by using Kibana or Python script. So sorry, oops. And step 2 then is automation of step 1. So how we did this in Hooker is first you prepare your Android device, and then you configure a scenario which will tell the Android device what it has to do. So install the application, execute the application. You can do some user stimulation. You can do some network stimulation, SMS sending and stuff like that. And you can also reboot your device. And then you just have to launch your experiment. And yeah, step 3 is just profit. So what you can do with the Hooker is you can highlight weaknesses in applications. You can highlight malwares within markets. You can find which market is safer than others. You can do a lot of things. It's just up to you. So we just made a little experiment a few months ago. We took the Hooker and we put in input 1,500 applications from the Google Play. And yeah, in output it generated lots of data. And yeah, just to give you an example, it's very quick, but it was a time when there was some Bitcoin miners on the Google Play. So we asked ourselves can we find some crypto miners? So we just computed the number of digest operations the different applications we analyzed did, and yeah, we found this. So here you have some applications that are highlighted by Hooker. So yeah, it's free, it's on GitHub, you can check it now and give it a try, play Hooker now.
Hello everybody, I'm Thomas from Aachen, and in our student storm we were building vending machines connected to the network for selling beer and condoms and chocolate and everything. It was great fun to build that, and I think you also need a vending machine like this. So I'll show you some pictures how we implemented that. The first thing in progress of buying is you need to charge your account. There you see the interface on our, that's another machine where you pay. So you press charge the beer account, and then you insert some money. Why is that clicker not working? No, that's too long to render. It's a battery, I think. You enter some money, that charges your account, and once you have balance on your account, you can go to the vending machine. There, the vending machine is. You see there is an iPad installed, which has an open web app, so it's very easy to buy a cheap iPad. It's 60 euros or something if it's used. And you enter your room number there. So my room number is 1314, and then the machine asks me, what do I want? So in this case, I can select whatever is in the database. The database always knows where how many products are, because we enter it when filling the machine. So I select a beer. It says, okay, it takes €1 for the, this clicker is shit. No.
Your slides are too big.
Yeah, your computer is too slow. Next slide. Yeah. Then this device gets active because it's sending a text message. The text message contains the BTAN. That's like a MTAN for banking, but it's for beer, so it's called BTAN. You get it on your mobile phone, and there's the message and the code. So you have to enter the TAN again. This clicker, this computer, yeah.
You are the first one experiencing this problem,
Yeah,
but we will give you one extra minute
I'm
for
the first one
waiting.
using PowerPoint, extract slides as pictures, and putting them in the PDF. Can you please next slide? Yeah, thank you. Then you have to press the engage button. Next slide. There's the button. Since resistance is futile, we call it the engage button. It's because if two bottles come, they will jam each other. So next. Then the kangaroo starts blinking. Next. Then there comes the beer. You see there's a Jever beer. Es könnte schäumen. Next. Then you open the beer. And next. And there is the Schaum. Next. Skip fast because it's just explaining how the database works. It looks up a PID and it's quite next. Yeah, this is internals of the machine. You see the cans. You should never, if you buy a machine, you should never insert some Bitburger because Bitburger bottles always break. So you want a beer and it comes out only beer and pieces of glass. So next. There you see how the old 80s, 1980s machine works. There is a small motor, electric motor, and you just need one additional cable. Next, which is connected to a Arduino Mega. Next, and there you see the Mega inside. There are two relay boards. It's very easy to program, and there is also an Arduino shield which connects to the network. So if I press the engage button, it queries the server, and if the server says, okay, slot 3, then there comes slot 3. So the server takes care of authentication that you entered the PIN. So that's done in the web application, and then the database knows that the next energy engage is right. Next. Yeah, this is the blinking. Next. Yeah, second machine is a spiral vending machine. It's also in our washing machines room because if you install some vending machines in public, you need fire extinguishing systems. We don't have that, so it's not in public because it's a private there. No. Next, there are. Next. This is the cable. No, back. This is the cabling of the Spiralautomat. It's a matrix. Yeah, you can watch a video there. You can contact me 4131. I also have 100 cheap energy drinks for sale. They need to go away. Please contact me. Contact information in the wiki. If someone is interested in implementing, I can also upload a code. It's very easy. Arduino. It's all. I'm not a good programmer. It's very easy to do.
Hello? Yes. Okay. So I'm going to talk about tamper-proof web apps. The way things work currently is the user specifies a URL and the browser fetches a bunch of resources and then runs it. Security is based on security of connection and the identity of the remote server. So, and you have to trust the remote server to give you the right content, which is usually fine, but increasingly web apps make promises about their own security. Things like private data never leaves the browser, and users should want to know if this behavior changes. And website providers might want to protect their users, even in the case where their own servers are compromised. So if we're running like a trusted page, then we can fetch and load more resources. But where do we get the initial piece of the initial page, the top level of the hierarchy of trust? And we always have to start with something that's already on the user's computer, like an HTML file with JavaScript in it. And we want this to be a nice shareable form, so that we can do a review, we can share it in lots of different ways, because the more ways you can share it and the more different copies there are, then the more you end up with a sort of decentralized security, because there's no single point of trust to start with. Now, actually, sometimes dealing with HTML files and attachments is a bit awkward, so do we have anything else which lets us share things more easily? And data URLs are quite good. So you can have, this is a plain text example, but we can use them for HTML documents. Obviously, the more JavaScript you pack in this HTML, then the longer the URL gets. So basically the question becomes how neat can we make this data URL so that it's as shareable as possible? There we are. Oop. So a minimal setup might be you have a verification function like SHA-256, and you have some acceptable hash values and then some loading logic. And this gives you data URLs, some around 1.5 kilobytes. And this is great, this works. It's a little light on features because it tries to fetch a single JavaScript file, and then if the hash matches, then great, otherwise nothing. I started thinking about JavaScript modules because, as well as being a nice way to organize dependencies, that would be a nice way to, a loader is a good way to implement behavior like fallbacks. So if your big resource bundle doesn't quite check out for some reason, then you can start looking in the backup locations and CDNs or even user-supplied places. So yeah, the setup I then ended up with is SHA-256, module loading logic, and then sort of the asynchronous fallback loading. And this gives data URLs around 3 kilobytes, and you can actually add features like verification using public key signatures instead of hash matching, or even other module formats like CommonJS, and you can add these as modules. There is, so I've got my reference implementation as caution.js. These are not the latest version of the slides for some reason, so my email is not on there, but my DECT extension is 4597. And I'm looking to make an initial proof of concept. And what I want is something where you can share encrypted files between two people over a service like Dropbox. So you'd give someone a data URL, and that means that both of you using that data URL would be able to exchange encrypted documents. And maybe this could be used for whistleblowers or just like private notes shared between people and that kind of thing. I've talked a lot faster than I did when I was practicing this, so I have a bit of time left. Questions or anything, I guess? Yeah, so the public one is sadly Gmail, luffgd@gmail.com. Yeah, do get in touch.
Okay. So actually, if you have more than 1 minute left, we might also have time for some questions. So now we just passed the 1 minute threshold, but there's some microphones there in the hall, so yeah.
And if you are a speaker and see that you're finished too fast and see that it's still green, you can ask for questions yourself. This is probably faster.
Okay. Can I start? Okay. Hi, everybody. I'm Jelena from Novi Sad. I'm here to invite you and to present our Hacker Congress that's happening for this time, third year in Serbia. It will be 2015 in September. So what is the Balkan? Balkan is Balkan Computer Congress that will happen in 11th, 12th, and 14th September in Novi Sad. In West Serbia.
Please use the monitor in front of you so you speak to the audience.
Okay. So, what is the Balkan? Balkan is Balkan Computer Congress. It's a national hacker conference organized by Lugons, Linux user group of Novi Sad, and Wow Holland Foundation from Hamburg and Berlin. This time it will be the third time we organize this congress. And our goal is to, on one place, get the hackers from the communities from this part of Europe, because there is a lot of hackers in this part of Europe, but they don't have so much opportunity to travel to Hamburg or the similar conferences in the Europe. So we want to share that experience on that conference, on our conference in Novi Sad. Why Lugans? Lugans is the oldest hacker community in Serbia, so it exists more than decades. So we, on 28th C3, we came to India to organize something similar CCC in Novi Sad. So, okay. The important dates and deadlines for the Congress. We will publish our CFP 1st of February next year, and the submission deadline will be until the 1st of July, and the conference will be from 11 September to 13 September. So, the important links, you can find all information about our Congress at balkan.org. We have video material from first Congress. It was First Contact, the name was. You can find it on our FTP servers and also on YouTube. And from this year, it's also on our FTP servers. You can follow us at Twitter also at Balkan2K15. For last year, it was 2K14. So if you are interested, if you have time, if you want to join us, share knowledge with us, if you're a programmer, hacker, artist, journalist, you're welcome, and we want to invite you to come and have party and have fun in Novi Sad next year in September.
So the next speaker is Obelix, I think. Is Obelix in the room? No? Oh.
This is actually the last talk before the break, so it would be really cool if the speaker showed up. Else there might be some problem like for him.
So, last request for Obelix, please proceed to the microphone.
Last call. Okay, well, then I guess we have to break early. So we are continuing at 1400 here. So this is in about 20 minutes. And yeah, so thanks for everyone who's been presenting so far. Awesome. So the speakers who are just arriving, can you please sit somewhere at the front so you can later quickly get to the stage? Thanks. welcome back. So please, everyone who's still looking for a seat, please sit down. Yeah, so this is the second half of the lightning talks for today. And just a quick reminder, speakers, you can please take a seat at the front. And if the previous speaker is about to finish, then just prepare to come forward. So we have a quick changeover. And your slides are down there, so you don't have to turn around, you know. And here's your microphone. Please adjust it. So the first talk is going to be about the Open Observatory of Network Interference. So where's my speaker? Okay.
Perfect. What I'm going to talk to you briefly about today is UNI, this project that we've been working on for, at this point, a couple of years. And what is UNI? UNI is basically a set of principles, guidelines, best practices, and more specifically test specifications for conducting network-related measurements. The sorts of network-related measurements that we do are aimed at identifying deviations from normal network behavior. That is, network irregularities that can be a symptom of internet censorship and surveillance. So what we are identifying is not necessarily internet censorship directly, but clues that can lead us to believe that that is what is happening. Our methodology is peer-reviewed. We have published a paper on it, and it is implemented using free software, and all of the data that we collect is made available to the public. So what is it that we detect? The two sorts of broad categories of measurements or experiments that we run fit under what is called either traffic manipulation, where we are trying to answer the question, is my traffic being intercepted? Is there some middle boxes that is performing deep packet inspection, that is downgrading, for example, the YouTube video that I am seeing? So we're not specifically trying to see if some particular types of content or keywords are being filtered, but we're just asking in general the question, is somebody altering the packets that I am transmitting to an endpoint that is under my control? The other broad category of tests that we have implemented is what we call content blocking. So here we are actually asking the question, what is being blocked? So what websites are unavailable, what keywords are triggering particular types of filtering. And so generally tests implemented, tests of this category will generally have an input list. They will take as input some lists of URLs, some keywords and whatnot, and we'll run through them and see which one trigger anomalous network activity and which ones do not. So why is all of this important? Why have we decided to work on this project? Well, we believe that making data on censorship available to everybody under an open license is extremely useful to journalists, to researchers, but also to activists that are interested in better understanding the phenomenon of internet censorship and surveillance. And when these people have evidence that is based on facts as opposed to just anecdotal reports, they can make a stronger case against internet censorship. And our goal is that of promoting transparency for internet censorship. That is, we believe it's important to have oversight, also in democratic countries, on how these systems are deployed and how they are used, because we have seen in the past and in the present a lot of instances of overblocking of sites that should not be blocked, that are in fact blocked. And so that's the reason for that. We think it's important to have open methodologies because only by having the test be specified and documented in English before it is implemented in code, will people then be able to verify that what we are testing, what we are measuring, is in fact corresponding to what we should be measuring. So only by doing this will we have results that are, that have scientific value. As I was saying, we focus a lot on tests. Tests are very important. Oh shit. Open implementation. Well, we believe in openness and open everything. These are some of our users. Come to our talk tomorrow and adopt an Uniprobe.
Yeah, that wasn't his fault. I made those slides for him, so blame me. I work as an internet engineering researcher at the University of Aberdeen, and I do a lot of work with internet measurements. So this is measuring, are you getting the bandwidth that is advertised by your ISP? Is your path broken for certain protocols? Are there middle boxes that are rewriting your traffic? And it's important to do these experiments in a real-world environment. Enter censorship, and suddenly you don't know what your environment is anymore. You don't know if you're measuring the network, the path, or if you're actually measuring the ISP censorship system. So we've got here some results from Open Rights Group block.org.uk's website, and you can see that on the TalkTalk strict setting, 13% of the top 100,000 websites 6 months ago were in fact blocked. Each ISP has a different block list. These are not actually maintained by the ISPs themselves. It's a third-party service. The ISP doesn't even know, to some extent, what is being blocked. There's no way of getting access to this information. So there's no way of verifying, once you've done your measurements, whether or not you've actually done good science or if you've been intercepted. Each ISP, a different way of dealing with it. So some will have an error page. Some will just send you a 404, some a 403. Ideally, there would be a system for looking these up. O2 has a system for this. You put in your URL, it tells you whether or not it's blocked. But of course, the ISPs don't really have access to this information, as far as I know, and so they're not providing the service. It's bad science. You publish these results, no one can base anything on these results. Because it's very difficult to verify that they're correct. So there's a number of solutions to this. Ideally, HTTP 451, which you may have heard of, unavailable for legal reasons as an error code comes back instead of a 404 or a 403, and you know you haven't spoken to the server you were intending to speak to, and then you can disregard that result. Microsoft actually have done something good here. With Windows parental controls, and they do return HTTP 450. This currently isn't in the standardization process as far as I could tell, but I would really like to see this adopted. So you've got an error code for this has been blocked for legal reasons, and an error code for this is something that you've opted into, and this is something you've chosen. So you can distinguish between the two. But ideally, there would be a way of just getting access to the lists, not even bothering to test the websites that are going to be censored. So yeah, that's all I've got there. So again, come along to the Adopt a Uniprobe talk tomorrow, 6 o'clock, hall 13, and I'll be there if you want to ask me any questions. Noisy Square, not hall 13, Noisy Square.
Any questions now, because we have 1 minute 40?
Should have let him carry on a bit.
Oh yeah, there's one.
The ISP needs to have, obviously needs to know the list, because otherwise they wouldn't be able to block it.
No. So what it is...
Who executes the blocking?
So they have hardware that's provided by a third party.
Oh.
It's in their network, but it's not controlled by them.
Oh, interesting.
Okay, great. Then let's thank the speaker again. And so the next talk will be in German. I think it's the only German talk today. And if you need a translation and have a DECT phone, 8014. So.
And before you start, I have a quick announcement. Please try not to obstruct the aisles. So if you're sitting on the wall and in the front part of the room, it's okay. But everyone sitting in the aisles behind the first half of the room, please move to the front or find a seat. We absolutely have to keep the emergency exits clear. Thank you.
All right, so sorry for the German slides, first of all, but I've decided to talk in English, so I hope everybody can follow me. My name is Stefan Hügel. I come from FIF, which translates to Computer Professionals for Peace and Social Responsibility. And I would like to introduce our Cyber Peace campaign we just started, and where we aim at the peaceful use of the internet without military misuse. I would like to recall first what's the problem today. We're all talking much about surveillance these days. And from our point of view, these kinds of surveillance which endanger human rights are in itself an act of cyber war, which we reject. For doing these surveillance, we need manipulations of communication infrastructure. We need the creation of vulnerabilities in internet devices. And this is an act of war, and this is not only our point of view, but also the point of view of the so-called Tallinn Manual, which was initiated by the NATO some months ago. We have today the situation that National Cyber Warriors Intelligence Agency, we can consider a hacker organization with also unlimited resources for hacking the internet. And these acts of war lead to a large potential of escalation and so endanger international security entirely. Moreover, it leads to the preparation of conventional military operations. We all know about drone strikes with mainly or many innocent victims without a trial, without even a suspicion against these people, which are killed by these drone strikes. And this also is prepared by the surveillance of the intelligence agencies. Last, we have a main problem of this kind of cyber war. We have the illusion of a clean war with not many victims. We can't see the victims, but this leads to the illusion of this clean war and lowers the senkt die Schwelle der Angriffe, of the attacks. So what do we call for? First of all, we call for the rejection of all kinds of cyber war, all kinds of cyber warfare. We call for the preservation of the integrity of all communication infrastructures and the entirely peaceful use of all communications infrastructures. We call for the peaceful use of these infrastructures. We call for protection of military misuse of the infrastructures, and we call for the preservation of human rights on the internet, in all communications. And last of all, we call for the rejection of a security doctrine which puts everybody of us under a general suspicion of being criminals. So, what are our targets? We want to influence. We want to take influence on security wars and security strategies, for example, by lobbying. We want arms control on cyber weapons. We want rejection of all kinds of offensive cyber weapons. We want a sensible form of publication of all vulnerabilities with a target to have them closed as early as possible. And this is all.
30 seconds.
Okay, thank you. This is all what we see as a secure communications infrastructure we call for in our campaign. And as a first step, we have prepared 14 claims you can find on our internet website. You can find us on the internet, of course, cyberpeace.fif.de, and you can find us on the nicest square on the first floor here in the Congress. Thank you very much.
Next one is going to be a special double feature of 10 minutes.
Yeah, thank you. Hello, Congress. I will talk about bootkits, but via SMS. I will talk about USB modem, 3G, 4G USB modem. It's a very complex device. If you don't know, it's a computer which you plug into your computer, but it also have one more computer inside. It's called a SIM card, but it's a different story. So there are a lot of hacks related to USB modems, but mostly it's related to firmware update, and vendors decide to harden these systems, decide to switch off additional interface and use only web interface, web dashboard to management. This was a mistake. Why? Let's talk about hacking USB modem. First of all, you need identify correct manufacturer. Why? Because it's very heavily branded. There are different ways. You can broke it, see inside, but sometimes very stupid tricks work. For instance, you can take a photo of this modem and Google via picture search and find correct model of the device. How 4G modems works? When you plug it into your laptop, operation system on modem boot up and works like router. So you have additional interface, you get IP address through the DHCP and work like through router, not with a wireless network of operator. If you have network device, we can scan it. Sometimes you can find even telnet on the system. And sometimes via simple Google search, you even can find password for this telnet. But sometimes you cannot find nothing because, for instance, it's a very new device. But we don't need just a password. We need a remote code execution, and HTTP is the best way at the moment. So we start to find vulnerabilities, and there are thousands of trivial web vulnerabilities like CSRF, lack of authentication, cross-site scripting, just a few examples. And these vulnerabilities can be used not only to write XSS in alert, but for our stuff. For instance, we can change DNS settings, SMS center settings to intercept SMS, manipulate with contacts, issue USSD commands, manage wireless network, and also we can brick device. And now I want to show you a short video to demonstrate how it can work in general. Here it is. This is a web dashboard of modem. Attacker can send SMS with cross-site scripting vector. Here it is. Sometimes it's necessary to read. Sometimes it works just by arriving. So, new SMS, let's read it. Just to be sure that is cross-site scripting. Here it is. So via this cross-site scripting, we can do different stuff. For instance, we can send USSD request to a provider asking to reset our password to self-service portal. Sending. After this, provider send us SMS with new self-service portal password. Via XSS, we can read it. It's hidden, sorry. It's my password. And we can delete this SMS to not bother the user. So we have a password to self-service portal, and we can, I don't know, subscriber to something useful like, I don't know, weather forecast for 15 euros per day. Slides, please. But I need the power. Sorry, I skip it. And it's easy to find it because I can say that with very poorly written web application, they use direct shell calls. They sometimes use AWK to calculate content length of the HTTP request, so you can play with it. And our different trivial remote code execution vulnerabilities. And we can get the shell. So we get the shell, for instance, it's a real request, launch netcat, get root access, and we can check this firmware. Sometimes during firmware assessment, you can find a lot of interesting stuff. For instance, CMD CGI. This is a backdoor. We can find it via black box. Why? Because web server is case sensitive, and during brute force we don't know that. But if we know where is a CMD CGI, we can execute any code without any vulnerabilities. Just ask it. So, but anyway, we have remote code execution on modem. What we can do? We get firmware. Yes, it's nice, but we can download it from internet sometimes. Find more bugs. We already have vulnerabilities. We can send SMS or USSD, but we can do it via SMSs or via cross-site scripting, trivial stuff. But what we want to own the subscriber laptop. So we can own modem, and the modem should own the laptop. How to do it? It's in USB, and all we know that USB is bad. Some time for coding, and in Google Play you can find a very useful tool. It's USB keyboard for Android. As I say, this modem is Linux device, Linux or Android device, so we can reprogram USB modem to be a keyboard. There are some technical issues related. We can discuss it later if you're interested. Now we'll see the demo. Okay, I see it on your screen. Oh, here it is. Let's assume that we already... Oops. Let's come back. Let's assume that somebody already hacked this modem via SMS, for instance, cross-site scripting and RCA vector, and we plug this device to our laptop. It will be detected like a network adapter. Here it is. A remote and this device. But after timeout, it starts to behave, oh, sorry, it's disclosure. After timeout, it starts to behave like a human interface device, like a keyboard, and keyboard can type. No hands, but it's typing. We launched calculator for sure. After we launch CMG, oh, it's but sorry. First we get BIOS specification, BIOS name and version, and after reboot the computer. When it rebooted, our modem became a CD-ROM. So, after all, for telecom, all your 3G, 4G belong to us. For everybody, don't plug computer into your USB, even if harmless network printer, but this story for next Congress. Thank you, with our team.
Hi, I'm talking about Void Linux. Void Linux is a new distribution based on the XPPS packaging system. First of all, before I begin, does someone already use Void Linux? Please raise your hands. Oh, great, nobody. One? Oh, cool. Arch Linux guys here? Sure, oder? Yeah, we got you. Okay. What this talk was planned like. First I would say something like, oh, Void Linux is great, Void Linux, use all Void Linux. Then some ranting about systemd, ranting about other distributions. I'm talking about you, Arch guys. And then I would talk about how great this package manager is. But then I thought, kitties. By the way, there's a great book on Amazon. And some more kitties. Okay, but obviously this would be bullshit. Why should I do this? Instead, I'm talking about some facts of Void Linux. We are using RUnit or runit, I don't know how it's spelled, how it's called, as an init system. We use no systemd, small asterisk, please applause. We have about 4,500 packages. Around 10 packages come to the distribution every week, so we are growing. We are using the XPPS package manager. It's written from the scratch. That's how it's looked like. It was started as a replacement for package source on NetBSD. Then it got ported to Linux and became the default package manager of Void Linux. It's optimized for speed, like all software is some kind of optimized for speed. But extra M, sorry, I always pronounce it wrong. But extra M measures every fucking operation this package manager can do. So Void Packages is our build system. It's, as I said, it has around 4,500 packages. About 3,300 can be cross-compiled to ARMv6, ARMv7, and also native compiled to x68, both 64 and 32-bit. These are the platforms, as I said, and we're supporting both the glibc and the moose-libc. And a great announcement, Juan, the maintainer of nearly everything, just managed to compile the live CD this morning on moose-libc. So when you download the ISOs on our website, you're getting the moose-libc per default on your live system. Oh, please applause. No, serious applause. Thanks, Juan. Okay, that's what build process is looking like. Here I'm compiling LCMA, and yeah, you're using templates files for this, and you're starting the build process, and you're getting both a repository on your local system and the compiled packages when the compile step is finished. and crossing quality is also in. Fast step, XPPS dgraph gives gives a short, gives your dependencies as a graphical output with graphviz. And any questions? No, we have no time. Seriously, thank you.
Yeah, so hello, my name is Matthias, and I fiddled around a bit with the WPA enterprise networks and discovered some, well, not so nice effects in the authentication security I want to talk about. So we're talking about password authenticated WPA enterprise networks. We have one here, the Congress network. And the prominent example is the Ethereum network, which is a network provided by a lot of universities to their students, which they can use worldwide to log into other universities' networks. Well, just a short question. Who of you uses the Ethereum network regularly? Who of you uses it on an Android device? Okay, so yeah, I come to that a bit later. This is a very short overview about how it works. So we have the Ethereum network. Then when you connect to the network, you use an anonymous identity to set up kind of a TLS tunnel. The server does not really provide an authentication to your device. It is just proved by providing a CA certificate. In the case of Ethereum, this is the Deutsche Telekom root CA2. Where nearly everyone can get a certificate which is signed by this CA. So, inside this tunnel, there's the MSCHAP v2 authentication. It's a challenge response method, but there's also the possibility to use plain text username and password authentication. So inside this tunnel, you just use your username and password to authenticate to the network. Well, so this is kind of a problem. Let's play man in the middle, create a network called Ethereum, use a patched host APD, which allows any user to log in, and well, just tell the device you want to use the GTC plaintext login instead of the MSCHAP v2 channel response. Well, then go to a public location, fire up your network, and lots of clients will try to connect to your fake Ethereum network. And unfortunately, a huge amount of devices will give their plaintext login information to you. So I'm talking of about 10% here, but I did not run any great field tests because the legal situation is not quite clear. But as you may have heard, also the MSCHAP v2 channel response is not quite secure. So there are lots of devices which will just supply you with a channel response hash, which you may use later to crack the username and password offline. Okay, so why do we have this problem? Well, it's mostly end-device support. We really need server certificate checking, and this is not implemented in a lot of client devices. Apple is a great positive example here because you have profiles which can be very easily installed on Apple devices. And additionally, I saw some Apple devices, or maybe all these days, use certificate pinning. So when you first connect to the network, it asks you to verify the server certificate, and then it remembers this certificate and will warn you if it changes. So this fixes the problem. But other platforms, especially Google Android, do not allow any kind of server certificate validation. Even if it uses the WPA supplicant underneath, there's no way to configure something like a common name matching. Yeah. I don't know how it is in other mobile platforms, but even on desktop Linux or Windows, we have the problem that it is mostly impossible, but at least very inconvenient to configure any further server certificate validation methods. So I have a few links here. When I discovered this issue, later I Googled about it, and a guy from another university also discovered it with eduroam and talked to eduroam people about it. Their answer to the problem mainly is the universities should provide better setup guides, but as I told you, this is not always the solution, because for some devices you cannot fix this problem. A really great advice would be to not use a common CA, but use a private CA for every network you set up. So there's also a link to my GitHub where you can download the patch toast APD. You can contact me here after the lightning talks outside or per email. Thank you.
Hi everyone, my name is Guy, or Shift. When I tell them my name, they don't understand it, so sometimes I say Shift or sometimes I say Guy. I'm gonna talk about hypervisors. I've been auditing the Zen hypervisor for the past several months. I didn't do any VTD escapes or TXT stuff for the stuff you've seen on Corey's and Rafal's talk, but I managed to get VM escapes from DOM-U to DOM-0 and from DOM-0 to the hypervisor itself. This is not going to be, I'm not going to give a lot of details here. This is just a teaser talk from what I'm going to show. So TLDR Zen is broken. Be careful if you use Amazon or if you try to use it on, I don't know, privacy stuff. So I'm going to show a short demo of what I did. There's not much over there than just me escaping from DOM-U to DOM-0. So if you're going to applause to Theresa now, it would be awesome. So she'll show the demo. So right now we see the host. We can see that lolz is the actual root, so you can see it here. It's kind of reducted, but fuck it. When I do ls, there aren't any stuff here, so I'm not bluffing or anything like it. And now we're looking at the guest here. I'm using root access, but if you're smart enough, you can actually escape from using a regular user. When I try to do ls on home lolz, it doesn't work, and so I'm on a guest, I'm not bluffing. Or at least just believe me. So now, using the actual exploit, this one is working on 4.1 and 4.2. We just escape. There's nothing to see here, but other than, okay, you can see it, but root lolz. So I'm not gonna touch now a file on the host. Nothing over there. Going back to the host. That's it. Enjoy.
We have still some time for questions if you want to answer questions.
Can you please use a microphone? I give you mine just as an exception.
Yeah, some of it.
And can you repeat the question, please?
Could you repeat? I can say that the mini OS sucks. QEMU sucks when it tries to emulate different kinds of stuff. I wouldn't recommend not many people use it. Be careful when you do it. That's it. I'm going to present more stuff like later. This is just a teaser, as I said. There aren't many technical stuff, as you can see, just other than this video, and it doesn't give much. So we can talk about it later if you want, and I'll show you some stuff.
When and where do you present more?
That's a good question.
The question was, when do you present more and where?
I think I'll do it in Syscan or something like it. I hope to.
Is it documented anywhere?
I think I'm going to drop it on Twitter or whatever.
Okay, thank you very much. So a big round of applause.
Well, this doesn't look like my slides. Ah, better. Okay, perfect. Can I go back? Cool. Okay. Hello, my name is Barne, and I will present to you the hackathon we did at CERN. CERN is an international organization for particle physics research, and as such, well, we have a lot of technology there. A lot of innovation and stuff that you maybe know from magazines and newspapers, but also stuff that you... This thing doesn't work. Okay. That you maybe use in your daily life, like the World Wide Web and touch screens. However, we asked ourselves, how can we use this old technology and innovative force that we have there for humanitarian purposes? And, well, we came up with some ideas, and we started talking to experts from the Red Cross, from UN organizations, other physicists and so on. And we thought, well, let's make some projects, let's make a hackathon, and let's try to get some functional prototypes out of it that can be used directly in the field. So we also tried to be a little bit experimental about this. So we didn't want to have like a group of people coming from one field of work. So we tried to be have heterogeneous groups as possible. So we gathered experts from science, arts, from private companies, NGOs, academia. We just were very open. We had a long selection process, and in the end formed these teams. So they had 6 weeks of intensive research phase. We gave them online workspaces to work on. And this was concluded by a 72-hour hackathon at CERN in the, quite inspiring environment of the EDA labs. We wanted our participants to leave their comfort zone and to think out of the box completely. All this has been closely followed and supported by experts that will hopefully use this in the end in the field. So we so we had 35 participants and 23 local mentors. They came from 28 nationalities, and I think this graph shows that we quite managed to have people from all fields of work. And they worked on these topics. So we had one thing which is terrain elevation determination for refugee camps. So you have to know where to put your refugee camp if you don't want to have it flooded after a couple of days. The other one was conflict zone humanitarian demarcation certificate, which means you need to label buildings, buses, camps, whatever, that they are not military. Otherwise, they could get attacked. And if somebody attacks these marked locations, then you can go to like a court and try to get the people that did all this attack court-martialed. The other thing is like improving the performance of demining dogs and rescue dogs. Our topics are $10 inflatable fridge for field operations, and this is more on the scientific side, portable cosmic ray detector, and Blind Store, which is a private information retrieval data store system. I will not talk about this anymore because it will be a talk in 10 minutes, so please stay here, stay tuned, it will be very interesting. From our point of view, the hackathon was a huge success. We had a lot of discussions, a lot of progress. People are very happy to be there, had a lot of fun, and in the end we had quite some working prototypes. So here's some results. So from the terrain elevation team, they built a nice app using GPS and data from the barometric sensors of mobile phones, and made a terrain elevation map from, the CERN premises at the time. Then the demarcation team made also an app that can authenticate personnel in conflict zones that they are really from humanitarian organizations. It's quite easy to use. It works via Bluetooth, and it works with certificates, and you can be quite sure, okay, this person is really well coming from Red Cross, for example. And there's also another idea how to mark buildings. From the fridge point of view, this project was split up into, well, they built actually a fridge that is very simple to build. It's very cheap, and they also worked on a new generation of body bags, so you can keep bad bodies safe and transport them safely. So that's it. Thank you very much. Well, if you have questions, I mean, there's my contact. It's 5319, or just go to this website.
Thank you very much.
Hello, my name is Nikoba, or at least you can find me in the big Congress wiki. And there are 5 people missing of our team, so I want to talk about Photopia, which is our ID, more or less. Maybe they are here, maybe they can stand up. One of them, there are 2, okay. 3, 4, 3 of them are stayed at home. And my goal will be to win your sympathy at least, and maybe also to win your some contribution or participation to our team. And
right here.
Okay. Okay, what is Photopia? Photopia should be like a community-driven picture database for social movements. So basically, we got tons of images in and hopefully tons of images out. And these pictures getting in are from, of, or with social movements as a subject. And they should go out to non-commercial media with some, let's say, idealistic motives, media who wants to spread the word, more or less. And as blogs or certain websites, print magazines, signs, posters, flyers. And the thing in between is the engine room. Sorry. I'm going to talk about later. And what makes us maybe a bit special is that we are non-commercial, so we are not like Flickr. It's a great difference because many people asked us what would be the difference. We are maybe from the left, you could say. We want to use Creative Commons license with the non-commercial module, which is very important to us. We want to be easy to use, and at least we want to be cool. And there's some history, because I stood here already 2 years ago in the 29th C3. And if you want to get more information about the idea, you can also visit this last lightning talk, where there's the URL. And now I want to talk about the engine room, because that's the point I want to focus on. That's a list of work to do we will going, or we want to do, or at least we think we have to do. And maybe I give you some time to read it out. I'm not going to read it out. And maybe you think it's fancy stuff you want to work with us on. And you can do that by joining us to our workshop, where we are going to discuss all these points. Today I learned maybe it's free software and not open source. There's a difference. I didn't knew that so exactly before. We want to write free software. That's our goal. And these are the dates, or these are the points where you can communicate to us. There will be a workshop at at 6 p.m. today. We are going to discuss all these topics. We're also on Twitter and Facebook, and maybe later on more cooler media. There's a blog you can visit, blog.photopia.cc. There's a website coming soon. Down there is our PGP hash. You can write us. And now, questions. Anyone?
Well, we only have 1 minute left, so I guess we don't really have time for questions, but I think you can find a speaker later on. We only have 1 talk left, and I think after the lightning talks, it will be possible to find some of the people who have presented.
Okay.
Hi, I'm Benny. I'm talking about Blind Store, a privacy-preserving data store. That's this one that was developed at the Port Hackathon. We started this project at CERN during our time as summer students this summer, and then had the opportunity to continue working on it in November at the Port. So what do we mean by data store? Well, it's a data store with some data. It's just n blocks of data with equal length. And the client can request a certain item number 3, for example, and he receives this data, but the server doesn't know which item the client asked for. So how do we do this? This kind of problems is called private information retrieval. There is one very simple approach. Just download all the things. But obviously, this is very expensive in bandwidth and takes a long time. So there are some methods to lower this resource usage. There is information theoretic private information retrieval. That's like you distribute your query in a way to multiple servers that if they don't collude, your privacy is still preserved. There are examples that work when only 2 stores don't collude. Then there's computational private information retrieval. There you need an algorithm that runs on the whole database, so that single store doesn't learn anything about you. That can be achieved with homomorphic encryption. So what's that? It's a very specific encryption scheme where we can run calculations on the ciphertext and get the same results then when you would run these operations on the plaintext after decrypting. So for example, if you have 2 plaintexts P1 and P2 and encrypt them to C1 and C2, then you add C1 and C2 decrypted, and it's the same result than just adding P1 and P2. So how is this used in computational PIR, for example? You encrypt the item number, send it to the server does some super expensive calculations, returns some data blob to you, and if you decrypted it with your private key, you get what you asked for. BlindStore just goes for this computational PIR approach. It's a library that provides functions for the client and the server part, and it implements an encryption and PIR scheme that was published in 2013. You have the name of the paper on the slides. If you download the slides, you have a link there to a huge paywall, so if you are not in a university network, you can contact me afterwards. I can show you the paper if you want. The complexity of this algorithm is very simplified with n, the database size, in communication log n, and in computation n log n. So that means if you have a database of 1,000 records with 1 kilobyte each record, then it takes 3 seconds to retrieve 1 record. That's a lot. I mean, a normal database would maybe take a millisecond. And the size of the data blob the server returns to you would be 2 megabytes. Okay, anyway, what can PIR be useful for if it gets faster? 2 points. You can be authenticated against the servers, but still your queries are hidden. And if you have a huge user base, still the server does not know anything about what the community is asking for, no statistics. Examples for this would be a DNS server, where the server does not know what domains are hip at the moment, or presence discovery, where you can ask the server if your friends are online or not, maybe get their current IP address to establish another communication channel. A question I was asked very often was, why is this different from Tor? Well, Tor hides your identity, but not what you ask for. So the endpoint or the service you access through Tor still knows what's happening. With BlindStore, it doesn't know nothing. But you can use Tor to connect to a privacy-preserving data store to even hide your identity. But this works, of course, only if you don't need to be authenticated. Then there's CryptDB, which does something with encrypted databases as well. You might have heard about it, but with encryptDB, the database is encrypted already, so it's only useful for one party. Some things like BlindStore can be used from a lot of people. We have to increase it in performance by 1 million to make it usable, but maybe we can do something like you need less privacy, yeah, then it's faster. Go to this talk, it's interesting, by Goldberg and 2 other researchers. They built this presence discovery service on top of PIR.
So this was the last lightning talk for today. Let's thank all our speakers again for walking up here and presenting their ideas and projects. And also, let's have a big round of applause for our angels who are working in the room, who are working hard on translating, on video, audio, and signal angels, and also Alex, who built the timekeeper and who brought it here and set it up, and yeah, so that's really great. There will be another round of lightning talks tomorrow, same time, same room. So stay tuned.